Good morning, ladies and gentlemen. To continue our lesson with electricity, we are going to talk about ammeters and voltmeters, which are basically designed to help measure current and the easiest way to remember how ammeters are connected in a circuit is to understand that because they measure current, they want to measure the same current as whatever's going through a resistor. Well, what kind of circuit has the same current throughout all the locations? Of course, that's going to be a series circuit. So that means that ammeters are always connected next to the resistor that they are trying to measure. If we take a quick look over here, we can see that in this case over here, this ammeter is measuring the current going through R2. Now, this ammeter over here is not next to any of the resistors in the circuit, but that's because it's measuring the total current, which is coming out of the battery. Okay, and that total current will also happen to be the current that is going through R1 as well. Now, the thing is, because ammeters are designed to measure current and they're placed in series, keep in mind every meter is designed not to interfere with the circuit. So in order to not interfere with the amount of current that's passing through, that means that the ammeter is designed to have extremely low resistance inside. So that way the current can pass through and won't slow down the flow of electrons at all. A voltmeter, on the other hand, is of course designed to measure voltage. But voltage, well, what kind of circuit does voltage stay the same in all locations? Of course, that's going to be a parallel circuit. So that means that voltmeters are always going to be connected on a separate branch, okay, a separate parallel branch. So if you look more closely at these pictures over here, notice that we have the same diagram, but now this voltmeter is on its own separate parallel branch that measures the voltage going through R1, and of course over here we have the voltage going through R2. If we wanted to measure the voltage of the battery itself, we would have put a voltmeter parallel to the battery. So whatever it is parallel to on a separate branch, that is what the voltmeter measures. But keeping that in mind, that current does go through, okay? Normally, whenever there's a parallel branch, whenever there's a junction, the current splits up into separate parts. So we don't want really any current going through the voltmeter. We want as little as possible. Otherwise, it's going to interfere with the resistor itself. So that means the way it's designed, voltmeters have an extremely high resistance inside to prevent much current from going through. Okay. Watch this video over here. Right now we have 3 light bulbs connected in parallel, and they're just going to show you how they use this galvanometer configured as a voltmeter to measure the voltage. And notice, keep in mind here that they have one clip coming attached to one side, and the clip from the other point attaching to the other side of the light bulb. So it's on its own separate parallel branches. However, if they want to configure it as an ammeter, now they're taking this galvanometer and they're switching it around a little bit. Notice, before the light bulb wire went straight through, okay, they disconnected one end and they attached one side of the light bulb to the ammeter, and then the other side simply continued on, meaning that now we have this ammeter that's next to the light bulb that's measuring. So it's placed in series with the light bulb as an ammeter. Okay, so always keep in mind, ammeters have to be in series, which means on the same line, and voltmeters always have to be placed parallel, which means across the component on its own separate branch. So if you take a quick look over here, if we were just to do this as an example question, they would ask, what kind of meter is each location? Number one has to be an ammeter and measures the total current because it's next to the battery itself. Number two also has to be an ammeter, but it measures the current of this resistor. Number three has to be a voltmeter because it's placed parallel, and because it's placed parallel, it knows the voltage of this resistor, but this whole thing is a parallel circuit, so it's actually the voltage of all the components in the circuit. And voltage 4 would be the voltage of the battery. Now notice voltage 4, voltage 3 would be exactly the same because this is a parallel